Right, Assalamualaikum and good day. For this video, I'm going to focus on the explanation of hybridization of central atom for molecules having multiple bonds. Today, I have CO2 as an example. So let's focus on the first step that you need to take before you describe the hybridization itself. Okay, number one, whatever it is, we must start with drawing the Lewis structure. Number one, don't forget, draw your Lewis structure. And second is always to draw the structure in its actual shape. That means you predict the shape. Yeah, so for CO2, of course, I skip the steps needed. Okay, you can do it on your own. Okay, so this is the Lewis structure and the shape is linear. Then, okay, now we can proceed with the description. Okay, knowing that the shape is linear and okay, if you look at the central atom, it has two sigma bonds and two pi bonds. Now let's start with the ground state. Right? Now we have the description for the central atom. C in its ground state has 4 valence electrons. For the orbital diagram, we focus on the valence electrons only. Now, carbon has 4 valence electrons in the second energy level. For the second simple quantum number. Right. Now, if you refer to the Lewis structure, look at the Lewis structure. Carbon forms 4 bonds, 2 sigmas and 2 pi's. Okay, so that is what you consider for the next step. Now, okay, the clue is, what is the clue? Of course, you don't need to write this on your exam paper. This is just a clue for you. Look at the number of sigma and pi. Right. So around carbon, we have 2 sigmas and 2 pi. And that equals to 4. So, having 2 unpaired electrons are not enough. We need 4. So, what do we need to do, or what needs to be done, or what happened in carbon actually? One electron that is paired, it is always from the paired electrons. Okay, the paired electron here will be promoted to the empty 2p orbital here. So since carbon is somewhat disturbed, it will be at excited state. Hence, it is unstable. Therefore, one electron is promoted okay, 2s to 2p. One electron here is promoted to the 2p orbital, and now we have 4 unpaired electrons instead of 2. And since carbon is at excited state and unstable, hybridization will happen to make it stable since hybrid orbitals have lower energy, right? So what do we consider? Here, the clue is, you look at the number of sigma plus lone pair, right? If we have sigma plus lone pair here, which equals to, okay, how many sigmas? 2 sigmas. And do we have any lone pair around carbon? No. Therefore, 2 plus 0 is just 2. That means in this case, the first two orbitals will hybridize. 1s plus 1p or mixes with 1p, and that will produce 2. Yeah, 1 plus 1 equals to 2, and we get 2 sp orbitals. And the energies are the same. What happened to the other two? The other two orbitals remain in its pure form. Yeah, 2p. Alright. Okay, now what about the terminal atom? Okay, the terminal atom, remember it is C bonded to O bonded to O like this. Okay, the terminal atom in this case, there are actually two oxygens, but the two oxygens have the same bond. Yeah, it uses a double bond which binds with carbon. Therefore, it is just the same orbital diagram. 2s and 2p. Oxygen has 6 valence electrons. So 1, 2, 3, 4, 5, 6. Okay, if we refer to the Lewis structure, yeah, it says that, or it tells you that one bond is sigma and the other one is pi or forms pi. So that means this will form sigma and the other unpaired electron will form pi. Alright, now let's sketch. We have carbon, yeah, the central atom, with two sp orbitals. Remember, the arrangement for sp is linear. This is carbon. Yeah. Label sp and sp with two unpaired electrons. And carbon also has two 2p orbitals. Yeah, pure 2p orbitals. I'm going to use a different color to that. Okay, my 2p has a dumbbell shape. Maybe I will have it like this. Yeah, this is 2p and one unpaired electron. And another 2p, maybe like this. Okay, I want to use a different color. Right. Excuse my drawing. So one unpaired electron here. So our carbon is done. Then let's sketch our oxygen. Okay, oxygen forms sigma bond, right? This is the oxygen on the right hand side, and it also forms pi. Remember, pi bond is formed when the orbitals overlap sideways. So I choose to draw one parallel p orbital, yeah, this one here. So the p orbital is parallel with the green one. It doesn't matter, you can choose the one in blue, no problem. Okay. And look at the spin. If this one points upward, so this electron must point downward. It is also 2p. And when they overlap, we get 1 pi. Alright, so don't forget to label. This is 2p, and 2p. And now let's sketch the one on the left hand side. Okay, maybe orange. Alright, so one here to form sigma. Yeah, this one is sigma. And another one, yeah, the other 2p orbital will overlap with this one, which hasn't been used, yeah, for overlapping. So I'm going to draw another one in blue, which slants to the left a bit. And since this one points upward, this electron must have opposite spin, and when they overlap, you get another pi. Don't forget to label. And that's it. Yeah. And this is oxygen. Right. I believe that's it. This is the sketch for the orbital overlapping diagram of carbon dioxide. Right. I hope you understand the description and help with your revision. Okay.